All right, so next up, we want to prove that the Qrs T is a parallelogram. There are a number of ways I could do this, but first let's go ahead and graph it. And I have done that, and I have QRS T. Okay, so there's QRS T. And there are three main ways I would suggest doing this. There actually is a fourth way, and honestly, there's probably more than that. But the three main ways I would suggest are the following. The most kind of obvious way would be to show that opposite sides are parallel, because that is the definition of a parallelogram. In order to show that opposite sides are parallel, I have to find the slope of QR, the slope of TS, and show that those are the same, the slope of RS, and the slope of QT, and show that those two are the same. So I'm using the slope formula 4 times and showing that opposite sides have the same slope, which is what makes them parallel. So that's one way. Okay. Another way would be to do the same kind of thing except with length to show that opposite sides are congruent. Distance formula for RS, distance formula for T. Show that you get the same thing. That means they're congruent. Distance formula for QR, distance formula for TS, and you've got the same length. And show that. And then you have opposite sides are congruent, and that is one of the main properties of parallelograms. So that's a second method. My favorite, however, is to show, this is what we're doing. We're going to show that the diagonals bisect each other. This is another one of the main, excuse me, the main properties of a parallelogram. And how are we going to show that? Well, to show that they bisect each other, basically we show that if you find the midpoint of one of the diagonals, R to T, and you find the midpoint of the other diagonal, QS, they are in the same place. Remember that a diagonal of any kind of polygon is just a segment formed by connecting 2 points that aren't already connected. So QS, these two are not already connected, and I probably didn't draw that perfectly. It looks pretty close. And RT are not already connected. So it looks pretty good here. It looks like they meet right here. It looks like our answer is going to be 3, -1, but we can't just say, oh yeah, it's 3, -1. It looks like that's going to be the midpoint of both of them. But if we do show that, if we can show that the midpoint of RT is 3, -1 and the midpoint of QS is 3, -1, or any other place, they're the same, then that shows that those two segments on either side of that point are congruent, and these two segments on either side of this point are congruent. And that's the very definition of diagonals bisecting each other. So that's what I'm looking for here. RT, I need to find the midpoint of RT. Okay, midpoint of RT. Remember, midpoint formula is the average of the two x's, so we add together and divide by 2. 1 + 5 / 2. Then the average of the two y's, so we add those together and divide by 2. And 1 + 5 is 6. 0 + -2 is -2. And this is the point 3, -1, just as we suspected. Okay, now I need to do the same thing for QS. Let's find the midpoint of QS. All right, -2 + 8 divided by 2. Add the x's and divide by 2. That's finding the average of the two x's, or the middle number between x's. The middle number between the two y's, add -3 + 1 and divide by 2. This gives me 6 / 2. This gives me -2 / 2, and just like before, we get 3, -1. Okay, so I would probably make a conclusion that kind of shows the reader what I have proven. I need to explain what I've done. And I say RT and QS bisect each other because they have the same midpoint. So Qrs T is a parallelogram. Now, I'm running out of room. Okay. Let me point out the reason I said this was my favorite method, okay, is because the other ways I could do it, if I want to show all opposite sides parallel, that's slope formula, slope formula, slope formula, slope formula. Okay, opposite sides are congruent. Distance formula, distance formula, distance formula, distance formula. Either way, if I'm doing something with the sides, I have 4 sides, so I have to do things 4 times. Diagonals, you only have 2 diagonals, so I just have to do midpoint formula once, midpoint formula twice, and I'm done. It just seems a little bit quicker to me, a little bit less work. But those other methods are just perfectly fine as well. Okay, so I hope this helped you, and I will see you next time.